Okay, so the question is the equation of two acid-base reactions are given below. In reaction A, ammonia reacts with water to give ammonium ion and OH negative ion, and they say that for this reaction the equilibrium lies towards the left. And in reaction B, amide ion reacts with water to give ammonia and OH negative, and they say that for this reaction B the equilibrium lies towards the right. Now for each of the reaction A and B, deduce whether water is acting as an acid or a base and explain your answer. So in reaction A we see that water loses a proton and form OH negative ion. So water is acting as a Bronsted-Lowry acid. In reaction B we also see that water is losing a proton to amide ion and forming OH negative ion. So here also water is acting as a Bronsted-Lowry acid. So the answer to the first part is that water is acting as Bronsted-Lowry acid in both the reaction, because water is losing a proton and forming OH negative ion. So water is acting as a Bronsted-Lowry acid in both the reactions. Now the second part, in reaction B identify the strong base, amide or OH negative. So in reaction B we see that the equilibrium lies towards the right. So equilibrium is towards OH negative ion and ammonia, and we know that equilibrium lies towards a weaker conjugate. So therefore OH negative is a weaker base and NH2 negative is a stronger base. So the answer is NH2 negative, because equilibrium lies towards weaker conjugate. Equilibrium lies towards weaker conjugate. Okay, so H negative is a weaker base and NH2 negative is a strong base. Now part C, in reaction A and B identify the stronger acid, ammonium ion or ammonia. So if we see reaction A, the equilibrium is lying towards the left. It means it is lying towards ammonia and water. So ammonia is a weak base because equilibrium lies towards a weaker conjugate. So ammonia is a weak base. It is acting as a base because it is accepting a proton. And ammonium is a strong acid, it's conjugate acid. So the answer is ammonium ion is a strong acid. Because in equation A the equilibrium lies towards the left and equilibrium always lies towards a weaker conjugate. Soluble acid and bases ionized in water. So sodium hypochlorite ionizes in water according to the given equation. Identify the amphiprotic species. So what are amphiprotic species in the given reaction? So water is an amphiprotic species because water can accept a proton to form hydronium ion, and water can also donate a proton like this. So what is amphiprotic species? Amphiprotic species are those species which acts as both Bronsted-Lowry acid and base. So here water is our amphiprotic species in the above reaction. Second part, identify one conjugate acid base pair in the reaction. So the conjugate acid base pair is OCl negative and HOCl. So OCl negative is acting as a base because it is losing a it is ejecting a proton, NaCl is a conjugate acid. Another pair can be water and OH negative. So water is losing a proton and forming OH negative. So water is acting as an acid and OH negative as a base, conjugate base. Now B part, calculate the amount in moles of sodium hydroxide used. So a solution containing 0.510 grams of an unknown monoprotic acid HA was titrated with 0.100 mole dm cube d moles per dm cube of sodium hydroxide. 25 cm cube was required to reach the equivalence point. Calculate the amount in moles of sodium hydroxide. So moles equals to concentration into volume. Concentration is given to us 0.1 and the volume is given to us in cm cube, so we divide by 1000 to get the dm cube. So 25, 40, so the moles equals to 0.1 divided by 40. Now the second part is calculate the molar mass of the acid. So we know that 1 mole of HA reacts with 1 mole of sodium hydroxide to give Na, A and water. So the moles of sodium hydroxide will be same as the moles of HA. So the moles of sodium hydroxide which we calculated in the part 1 will be equals to mass of the acid divided by its molar mass, because the moles of sodium hydroxide will be equal to the moles of HA. So this is the moles of NaOH that will be equal to the moles of HA, and the moles we calculate by dividing mass over molar mass. So therefore molar mass will come out to be this. So the molar mass will come out to be 0.510 multiplied by 40 divided by 0.1. Now the third part, calculate the H plus ion concentration in sodium hydroxide solution. So sodium hydroxide concentration we know, it is given to us 0.1 mole per dm cube. So this will be the concentration of OH negative ion, because NaOH is a strong base. So this is OH concentration, OH negative concentration. So we know that H plus ion concentration multiplied by OH negative ion concentration is ionic product of water. So therefore H plus ion concentration will be ionic product of water, which is 10 to the power minus 14 divided by OH negative concentration. So this will be the concentration of H plus ion. Okay, so which graph would be obtained by adding 0.10 mole per dm cube HCl to 25 cm cube of 0.10 mole per dm cube sodium hydroxide? So which is our titrant and which is our analyte? So our titrant is HCl and our analyte is sodium hydroxide. So in our burette, so this is my burette and this is my conical flask. So in my conical flask we have sodium hydroxide, and in my burette I have HCl. So HCl is my titrant and NaOH is my analyte. Okay, so the titration curve will start from the pH of NaOH. So NaOH is a strong base, so pH will be more than 7 and will be close to like 10 to 14. So which graph is good? Either B or D or C, but the option will be B, because this will represent the pH of NaOH. NaOH is a strong base, and since this is a titration between a strong acid HCl and a strong base NaOH, therefore there will be a sharp drop in pH like this, and then there will be a flattening of curve at very low pH. So B option. Okay, so a titration was carried out to determine the concentration of 25 cm cube of an aqueous solution of nitric acid. 0.100 mole per dm cube sodium hydroxide solution was added, and the results are shown in the graph below. So this is a titration between a strong acid and a strong base, and the strong base sodium hydroxide is acting as a titrant and nitric acid is a analyte. So we have sodium hydroxide in burette. So this is our sodium hydroxide here, which is acting as a titrant, and nitric acid is this is our HNO3. Nitric acid is our analyte. So what they are asking, use the graph to determine H plus ion concentration of the nitric acid. So what is H plus ion concentration of nitric acid? So we see the graph is starting at this pH. So between 0 and 2 pH they are divided into 5 intervals, and this titration curve is crossing at second interval, so which is equal to 0.8 pH. So we can say that the pH is 0.8, and from this we can find the H plus ion concentration. H plus ion concentration is equals to 10 to the power minus pH. Okay, so this will be the value. Second, determine the pH value when H plus ion concentration decrease to this. So H plus ion concentration now becomes 10 to the power minus 3 mole per dm cube. So the pH will be equals to minus log to the base 10 of H plus ion concentration. So this comes out to be 3. Use the graph to determine the volume of 0.100 mole per dm cube aqueous sodium hydroxide solution needed to neutralize the nitric acid. So in order to completely neutralize nitric acid, the volume of sodium hydroxide required will be obtained from the equivalence point. So the equivalence point, at equivalence point, what is the volume of NaOH? So this point. So this is 25, 26, 27, 28, 28 cm cube. 28 cm cube. This point. Yeah. Then the last part, calculate the concentration in mole per dm cube of nitric acid. So we know that nitric acid is a monoprotic acid, and it will react with sodium hydroxide, 1 mole of acid and 1 mole of sodium hydroxide to give sodium nitrate and water. So this is a neutralization reaction. So 1 mole of nitric acid react with 1 mole of sodium hydroxide. So the moles of sodium hydroxide will be equal to the moles of nitric acid. So what is this? What are the moles of sodium hydroxide? So moles of sodium hydroxide is concentration into volume. So what is the concentration? 0.1 mole per dm cube, and the volume is 28. Divide by 1000 to make it into dm cube. So this is our moles. So this moles of sodium hydroxide equals to the moles of HNO3. So the volume of HNO3 is given, which is 25 cm cube. It's given in the question. So therefore the concentration of HNO3 will be moles, this is the moles, divide by, this is 28, wait, this is 28. Okay, so 0.8 into 28 over 1000 divided by volume. Volume is 25 divided by 1000 to change into dm cube. So this will be your concentration of nitric acid in mole per dm cube.